59 हो गया टाइम. Hey guys, what's up? Back to this amazing session of JEE Sprint where we will sprint through chemistry, and today's topic is coordination chemistry. How you guys are doing? Kaisa hai Josh? How is everyone doing? Just let me know. All are well, and we are gonna start the session. All right, let's go. Bamanos, what's up? So I've been reading your chats. I like the intro. Very nice, so good. So just let's start, man. So the first question, I'll get a side. मैं side आ जाता हूँ. Read the question. And give me the answer, and I'll help you find the answer step by step. So everyone, please go ahead. Among the following things, among all the complexes, you have to find how many paramagnetic compounds are there. How many paramagnetic compounds are there? Let me know. What is the correct answer? And this question came in JEE Advanced 2016. Again, I'm going to show you how easy chemistry is. Okay? All right. Very nice. Give me, I am getting some answers. Come on. C. Someone is saying C. Someone is saying A. All right. Come on. Some of you are giving the right answer. Very good. I see some of them are giving right answer. Yes. Very nice. So beta, answer is, I'll teach you the relevant theory one by one. Answer is 3. Option B is correct. Some of you got it right. Very nice. Let us see how is that. Let us walk through it. First, I have NiCO4. Bacho, what is the oxidation number of nickel here? Oxidation number of nickel is here 0 because CO is a strong ligand, okay? And it is a neutral ligand. So oxidation number on nickel would be 0. And nickel is 3D8 4s2. Then what will happen, bacho? Pay attention. This is your 4s. This is your 3D, 5 electrons, 6, 7, 8. Now what will happen? Because of this strong ligand, they will pair up. Kya hoega? They will pair up. Yes. This electron will pair up here, and these two electrons also will come here. As a result, you will end up with no unpaired electron. There will be 4s empty. So here no unpaired electron. It means this cannot be your answer. It cannot be paramagnetic. All right. पहली चीज clear हो गई. I am erasing this. इसे हटा देता हूँ. ठीक है? Now next, move on to next. Trick दिखाऊंगा इसका कैसे हो जाएगा. NiCl4 -2. ठीक है? Here nickel's oxidation number would be +2. सब लोग जानते हैं. Everyone knows that. So it will become 3D8. But here बच्चों, very important thing, very crucial thing. Cl is a weak ligand. Cl कैसा है? Weak ligand है. So it's a weak ligand. As a result, draw the d orbital. This is your 3d orbital. 1, 2, 3, 4, 5, 6, 7, 8. Now, would these two electrons pair up? No pairing. Very good. Some of you are answering. I like that. So no pairing. As a result, there will be unpaired electrons. It means yes, it is showing unpaired electrons. Moving on to the next one. ठीक है? Moving on to the next one. This complex CO, it's a octahedral complex. Ammonia. How many times ammonia is there? 4 times. Cl2 Cl. अच्छा बच्चों, first thing very important. Ammonia is a strong ligand. Ammonia कैसा ligand होता है? ये point, these points we have to learn. It's coming from, electro splitting. This is experimental order. You have to remember that ammonia is a strong ligand. First point clear. All right. Now check this out. Let us find out what is the oxidation number of cobalt. So X, and ammonia is also a neutral ligand. X plus -2, because chlorine oxidation number, or you can say charge, will be -1 into 2 is -2 is equal to +1, right? So X will come how much? X will become +3. Cobalt bachcho, it is nothing but 3d7 4s2. So cobalt +3 would become what? 3d6. An amazing thing is, if I will write the d orbital 1 2 3 4 5 6 7, sorry 6, I'm really sorry, है ना, 6 तक भरेंगे. But as I told, ammonia is a strong ligand. What will happen guys? Again it will pair up. ठीक है, ये सब pair up हो जाएगा, ये pair up हुआ, ये pair up हुआ. So it will actually will not have any kind of unpaired electron. तो यहाँ पर भी this is also not paramagnetic, this is diamagnetic. Now guys, next up, I think you guys can see, check this out. This will be x plus, direct लिख रहा हूँ यहाँ पर, I'm writing directly. So x plus minus 6 will be equal to minus 3. So x will come as plus 3. Again cobalt is becoming plus 3. But this time guys, all the ligands, the fluorines are weak ligand. So pairing will not happen. Pairing यहाँ पर नहीं होगी. So this will become paramagnetic. This compound will become paramagnetic. So far, how many? So far we have found out that there are NiCl4 and this complex. 2 are paramagnetic. Now check this out. Check this out. Very, very important. JEE has asked this question. It is 2016 advanced question, right? JEE has asked this question. They have added here Na2O2. It means nothing but O2 2 minus. This is called as peroxide. How many electrons are there? 18 electrons. Peroxide, 18 electrons. Diamagnetic. Okay? This answer is coming from MOT. Actually, it is not a question of, coordination compound. It's a question of chemical bonding. MOT का concept है ये, right? So this you remember, 18 electrons. That's why it is diamagnetic. ठीक है? Similarly, if I talk about CaO2, this will become O2 minus. This is nothing but superoxide. It will have how many electrons? 17 electrons. Shall I give you a trick? एक trick बताऊं? Shall I give you a trick? Whenever you have odd electrons in MOT, it will definitely be paramagnetic. If it is having even number of electrons, total number of electrons are coming even, then go for MOT. Then you have to actually write and find the answer. But if the number of electrons are always coming odd, paramagnetic is your answer. ठीक है? तो ये this is a trick which we can actually आराम से याद कर सकते हैं. ठीक है? तो यहाँ पर आया, sorry, this is cesium. This is cesium बच्चा, है ना? This is cesium. So this is 17 electrons. So this will become paramagnetic. यानी कि how many compounds are there which are paramagnetic? 3. I hope सबको समझ आया, सबको clear हुआ. क्या सबको समझ आया? Everyone is understanding. तो हमारे पास CSO2 था, that became paramagnetic. NiCl4 2 minus became paramagnetic, and Na3COF6 became paramagnetic. Very nice. हाँ जी, चार्ज देखिए ना बच्चा, O2 minus यहाँ पर ये, बहुत बढ़िया. Easy peasy. All right, बच्चा लोग. So this question came in advance. How easy is that? Did we do anything extra here? बड़ा simple सा सवाल था. Now I'll tell you how repetition, how many times you will see a concept is repeating itself. In today's session, my aim is always to make sure to show you guys that JEE is actually a repetitive test, and you guys can easily crack chemistry exam if you follow my instructions properly. Moving on, ठीक है? Very nice. So here I'll quickly again introduce myself. I'm Harsh Maheshwari. Some of you guys know me, some of you don't. So now you will get to know me. ठीक है? So this is me, as you can see. All right, बहुत सही. Then guys, we are learning coordination chemistry. This is our today's session. And yesterday Pulkit sir has given a heavy lecture. I have seen the lecture. बहुत सही था, right? And then followed by Suri sir class. आज you have Suri sir class. ठीक है? So stay tuned. We have lot many things packed up for you guys as usual. ठीक है? Very good. Moving on. Next question. Waste नहीं करना है time. बहुत सारी चीजें करनी है. Check this out, guys. Check this out. Read the question. Read the question and tell me the answer. जल्दी से आप आंसर बताइए. Very good. Tell me the answer. जल्दी से बताइए. हमने अभी just now we have solved. What is the correct answer? What is the correct answer? Some of you are giving the answer. Very nice. Answer is B. Answer is B. Answer is B. And see how bacha question it is, man. Again, it is coming in mains, matlab AIEEE 2008. It has been a previous year question. Bada hi aasan question. How do we do that? You guys already know. Abhi just now I have discussed NiCO4. Since it is a strong ligand, there will be no pairing. It's a strong ligand, no pairing. Sorry, I'm really sorry. Pairing will happen. Pairing will happen. And as a result, and nickel here is 3d8 4s2. Everything will pair up. everything will pair up. 1 2 3 4 5 6 7 8, right? This will be S, this will be P. So this will become DsP2. This is 3D, this is 4S, this is 4P. So this will take DsP2 hybridization, sorry sp3. मैंने एक छोटा सा गलती कर दिया, प्लीज मुझे माफ करना, I did a mistake. So here all things will pair up. You will end up with 4s 4p. You will get sp3 hybridization. ठीक है? Even though cobalt is a strong ligand, even though cobalt is a CO is a strong ligand, even though CO is a strong ligand, but it will cause pairing. Everything will pair up and you will get sp3 hybridization. So first we'll get sp3. Let's go for next one. What about next one? Next one, NiCN4. NiCN4 -2. Here बच्चों, your nickel will have +2 oxidation state. It will become 3d8. ये 3d8 बन जाएगा, right? This will become 3d8. Now what will happen? Now again, CN is there. It will cause all the things to pair up. 1 2 3 4 5 6 7 8. This electron will also pair up, right? So you will end up with this is your 3d8, 4s, 4p. So this will become DsP2. Previous one, the oxidation number of previous metal here oxidation number of nickel was 0. In this case it is becoming +2. I hope it is clear. सबको समझ आ गया. So first one would be sp3. Pairing will happen. All the electrons will pair up. S electrons will also enter d orbital. Right? Very nice. And then in the next one, since the electronic configuration was 3d8, one of the d orbital would be remaining. Answer आ गया. How easy the question was. Again, very nice. क्या आगे बढ़ जाए? Shall we move on to the next one? क्या मैं फिर से आगे बढ़ जाऊं? Yes बच्चा, S block will come on time. Don't worry. We will also do S block. So don't you worry. ठीक है? Easy peasy. Next one. बहुत सही. क्या सबको मजा आ रहा है? सबको क्लियर हो रहा है? क्या इतना आसान सवाल पूछे जाते हैं? How easy questions are there? My aim is to show you कि how easy the chemistry paper is. I am actually trying my best to show you can easily crack chemistry. आराम से आप तोड़ सकते हो chemistry को, फोड़ सकते हो. Very nice. So move on. Let's move on to the next one. Read the question. This is a very heavy question. Be careful. This is a very good question. I personally love this question. So I'll give you all the theory about it, everything. Pay attention and give me the answer. Try, everyone first try. So with the following metals, metal carbonyls are there. CO bond order is lowest. They're asking where the CO bond order would be lowest. Did I do something? Sorry. Hanji. CO bond order would be lowest. Answer is? Okay, some of you are giving right answer. Very nice. I'm loving it. Very nice. Very nice. Heavy, man. Heavy. So the correct answer is D. Let me walk through the theory. Through the theory. Do you guys want the theory for it? Do you want the entire theory to be taught? कैसे बनता है? क्या मैं समझाऊं? Once I teach you the theory, you will never go wrong. Shall I teach you the theory? Shall I teach you the theory? Yes. Very important question. Stay tuned. ध्यान देना. जरा देखो. Carbonyl group बच्चा CO. If I talk about CO, देख you can see. This is a strong ligand. This is a very strong ligand. And this has this kind of thing will happen. Your metal. This is your carbonyl. Carbonyl will, give a pair of electron through coordination bond. It will give a pair of electron to metal. Now metal has electrons within. Electrons are also there in the metal. This metal will say, oh, so many electrons are coming, I am not stable. So it will try to, remove the electrons, try to, decrease the number of electrons on it, and it will give a back bond. It will actually, start donating the electrons back to carbonyl group. This actually makes a double bond or partial double bond, or which you can also call back bonding or synergic bonding. You might have learned back bonding या फिर synergic bond, right? So this, what is happening? Carbonyl is giving the electrons to the metal. Since metal already contain electrons, it will say, oh, I'm becoming unstable. I will give you the electrons back. वो electrons वापस देने लग जाता है. It will start giving the electrons back, forming a double bond, partial double bond, and we call this phenomenon as back bonding or synergic bonding. One thing, ठीक है? Now very very important thing. So here, what is happening? But so if I talk about d orbitals, if I show you the orbital diagram, this will be the orbital diagram scenario. और ऐसे दिखा देता हूँ, ठीक है. What has happened? First, it has given the electron to the metal. Metal already had electron. It will say, oh, I am not stable. I want to give the electrons back to you. So it will start donating the electrons backwards. This is called as synergic bonding or back bonding. First thing. Now pay attention. What will happen? Due to this, very, very important, this orbital where the electrons are going in the carbon, it is pi star orbital. Anti-bonding orbital. Okay? It is an anti-bonding orbital. So this point, keeping in mind, if I talk about what is happening to metal carbon strength, bachcho, you will say, sir, metal carbon bond strength is increasing. It means metal carbon bond length will decrease. I'm giving an extra point. Bond length will decrease. Very, very important point. If you want to take a screenshot, please take a screenshot. बहुत important point है ये. Please take a screenshot. Shall I move on? मैं आगे बढ़ता हूँ. ये concept समझाया है यहाँ पर. Very nice. बहुत सही. If this concept is clear, moving on to next point. इसी में. Then I'll ask you the answer. Okay? So stay tuned. All right. This is clear. Now, as I told you, the electrons from the metal are going into the anti-bonding orbital of carbonyl group. So what will happen? You guys know, if I talk about carbonyl group, you know, bond order is equal to half of number of electrons in bonding minus number of electrons in anti-bonding. है ना? So here, if number of electrons in anti-bonding will increase, so what will happen? Bond order will decrease. It means bond length of CO will increase. CO का bond order बढ़ जाएगा. CO का bond order बढ़ जाएगा. बहुत important, बड़ा heavy point है ये. ठीक है? It means overall, if I try to teach everything overall, metal carbon bond length, you know, it is going to decrease. It is going to decrease. And metal carbon and carbon oxygen bond length, it is going to, bond length is going to increase. If I try to make a note out of it, एक note दे दूं जिससे आपको पूरा, you can solve any kind of question given in front of you. Can I give you a note, a gist of everything what I have taught? Can I give you a gist? With that, any kind of question you can solve. Any kind of question on this basis. Can I give you a gist? इतना सोचना भी नहीं पड़ेगा. Need not to think this much also. Check this out. Very good. I like the approach, man. I like the approach. Note डाल के कहीं ना कहीं लिख लेना. You write this along with me. Note. If negative charge on metal increases, अगर metal पे negative charge बढ़ेगा, तो electron density on metal will increase. Electron density on metal will increase. So back bonding will increase. So back bonding will increase. If back bonding will increase, बच्चा लोग, metal carbon bond length decreases, and metal carbon bond order increases. But what about C double bond O? It means from the back bonding, it means if back bonding will increase, what will happen to C double bond O? CO bond length will increase, and CO bond length will increase, and CO bond order will decrease. Now, based on this answer, based on this note, this only happens in carbonyl. किसी और ligand की औकात ही नहीं वो कर दे ऐसा. Only happens in carbonyl. Based on this concept, check out where metal has the negative charge, highest negative charge, or oxidation number of metal is coming in negative. So back bonding would be maximum. As a result, CO bond length would be very, very high. It means bond order would be less. So what will be the answer, bacha? So what will be the answer? Tell me the answer now. Based on this, what will be the answer? Quickly tell me the answer. The answer should come up in the chat box. D should be the answer. Very good, because here oxidation number of vanadium would be -1. This is oxidation number. So metals can also have oxidation number negative. So in complexes, metals also have negative oxidation number. This is a very, very important point. Cyanide, yes, it can do back bonding, but not of that strength as carbonyl. Some of you has asked, sir, what about cyanide? Cyanide can also do, but not of that strength, not of that limit as carbonyl can. So it is also out of the picture. Only carbonyl can do back bonding. I hope this is clear enough. ठीक है? And who's not getting this? You can watch it in replay. आपको आराम से समझ आ जाएगा. Many of my friends are understanding. I'm liking that. ठीक है? Very nice. How to know oxidation number? Check this out. X, carbonyl is a neutral ligand. X plus 0. What is the overall charge? Plus 1. So X will be here. The oxidation number would be plus 1. Here it will be 0. Here it will also be 0. Here what is the oxidation number? Minus 1. Here what is the oxidation number? Minus 1. How did I write? X plus 0. Overall charge is minus 1. So X is equal to minus 1. So as I said, if negative charge on the metal ion increases, back bonding increases, carbon oxygen bond length will increase because the electron is going into the anti bonding orbital of C. ठीक है, कार्बन के एंटी बॉन्डिंग में जा रहा है. बहुत बढ़िया. Which groups can do back bonding? Only carbonyl. आपके syllabus में you have only carbonyl where back bonding can happen. Cyanide can never go for back bonding. So I hope I have also given. Maverick, please repeat. वापस आप देख लीजिए बच्चा. Please watch it in the replay. Next question. ठीक है? Maverick, I got your point, man. You can watch it again. आपको समझ आ जाएगा. ठीक है? थोड़ा सा मैं मान के चल रहा हूँ. Every student of mine is coming little bit prepared. हल्का सा he knows the concept. Then you can actually connect very well. ठीक है? The point of the sprint is this, and I'll give you theory as well. So do not worry. I'll always teach the apt theory. ठीक है? Very nice. Next turn. Next question to all of you guys. Check this out. Very important question. This question also came in JEE. So can you see carbonyl पे कितने सवाल बन रहे हैं? Again the question, repetitive pattern. Are you seeing it or not? Very nice. What will be the answer, बच्चा? What will be the answer? What will be the answer? Just now I told. Some of you have given right answer. Arya, come on. I want more answers. Very nice. So there is a bit of doubt. हल्का सा doubt है, पर मैं समझा देता हूँ. Answer काफी लोगों को सही है. Very nice. Answer is बच्चा A. Answer is A. Just now I told the point. Whenever carbonyl bond would be there, there will be back bonding because electrons are coming into the anti-bonding orbital of the carbon. As a result, C double bond O bond length, CO bond length should increase. वो बढ़नी ही चाहिए. Actual में it is always 1.128 angstrom, but it has been known and found that whenever carbonyl is forming a complex, it will go to 1.15 angstrom. आप ऐसे भी लिख सकते हो 1.150 angstrom. This you have to learn. ठीक है? ये point it is coming from experiment that carbonyl CO bond length is actually 1.128 angstrom normally, but in a complex, whenever it will form a carbonyl complex, the bond length will increase. As I told you, what is the reason? Because of the back bonding. All my sailors, are you understanding? सबको समझ आ रहा है? Clear हो रहा है? Very nice. Shall I move on to the next question? How is the Josh? Shall I move on to the next question? B नहीं है, वो तो बिल्कुल सेम हो गया ना बच्चा, 1.128 angstrom. उसमें तो कोई चेंज ही नहीं आया. Because of back bonding, the carbon oxygen bond length increases. वो बढ़ जाती है. Very nice. I like that, man. I like the. It is always 1.15 angstrom. ठीक है? बरखा. So need not to worry. This question is asked. I am giving the answer. ठीक है? All right. बहुत बढ़िया. Very nice. आगे बढ़ता हूँ. 1.28. अच्छा 1.28 नहीं होगा. किसी ने पॉइंट आउट करा 1.28 नहीं. It is 1.150. थोड़ा सा बढ़ जाता है. This is the value. ठीक है? So you have to learn this. Yes, 1.128 is way too big. The experimental value is 1.15 angstrom. तो ध्यान रखना. All right. Very nice. Moving on. Next question. My favorite question. Very daunting structures, but very, very easy. What is the correct answer? This is EDTA, your favorite compound, ethylene diamine tetraacetate. What is the answer for this? The correct answer. The correct answer. I'm waiting for the answer. C. Very nice. Answer is C. Very nice. Very nice. Acha guys. They appear very difficult. Shall I give you a shortcut to remember? क्या shortcut जानना चाहेंगे? How to remember the structure of EDTA? And I'll give an extra point as well. I'll give you guys an extra point as well. Check this out. देखो नाम है इथिलीन. So what you will do, CH2 ethylene. ठीक है. Diamine, there will be nitrogen, there will be nitrogen. Acetate means acetic acid. Acetate means substitution. Instead of writing 2H2, you will write the hydrogens are replaced by this acetate ion. The hydrogens are replaced by, ठीक है, ethylene diamine tetraacetate. The hydrogens has been substituted by CH2COO minus. That's the simple way of remembering. ठीक है, CH2 NN. The hydrogens are replaced by CH2COO minus. I hope it is clear. सबको समझ आ गया, सबको क्लियर हो गया, राइट? सो देयर इज अ मिस्टेक बच्चा, थोड़ा सा मिस्टेक है. ये सिंगल बॉन्ड है, ये सिंगल बॉन्ड है. अब ठीक है, ये सिंगल बॉन्ड है. दिस शुड बी अ सिंगल बॉन्ड. हाँ जी बेटा, बिल्कुल सही. आई गॉट योर पॉइंट. दिस शुड बी अ सिंगल बॉन्ड. इज दैट क्लियर? आगे बढ़ जाओ. सबको समझ आ गया? देख लो आप क्वेश्चन, आंसर देख लो पूरे. मैंने ट्रिक भी समझा दी है, राइट? आई होप इट इज क्लियर नाउ. यस, मूविंग ऑन. Aha, very nice. Check this out. What is the correct answer for this? What is the correct answer for this? Which of the complex will show spin magnetic momentum as 2.82 Bohr magneton? What is the correct answer? What is the correct answer? बड़ा ही सिंपल है, देख लीजिए. Just now we have mentioned this will be diamagnetic. आज की सेशन में पढ़ा. Are you seeing the repetitive pattern? मतलब पैटर्न कितना रिपीट हो रहा है? One second. Are you seeing the pattern? How much pattern has been repeated? Are you seeing it? Carbonyl compounds has been asked so many times in one way or another. In one way or another. ठीक है? This we have discussed. This is, you know, diamagnetic. We will not talk about it. Check this out. What is this? 3D8 plus weak ligand. बच्चों, whenever 3D, I am giving you an extra trick. Whenever you will find 3D8 attached with a weak ligand in a tetrahedral complex, in a, you know, whenever coordination number is 4, keep in mind it will be always sp3, and the electrons would be 1 2 3 4 5 6 7 8. And since chlorine is a weak ligand, it will never go for pairing. So how many electrons you see here? 2. One more pro tip. If 2 electrons are there, your Bohr magneton value, your magnetic moment would be nearly 2.82 only. जैसे अगर 3 होते तो you would have said 3.82. It is a very easy way of remembering it. Need not to find by the formula under root n into n plus 2. No need to use. Time बचा लो ऐसे, ठीक है? You can save your time here. सबको समझ आया? अगर 2 आते हैं तो 2.82 आंखें बंद करके. अगर 3, you would say 3.8 approximately. Very good. Again I will repeat the trick. देखिए, how many electrons you are seeing? How many unpaired electrons? 2. So instead of using the formula under root of n into n plus 2, you can skip that. If 2 electrons are there, directly answer would be 2.82. If you solve it, answer would come approximately this only. ठीक है? So why we waste our time? If 3 electrons are there, 3.82. We will directly say that. Got it, guys? आगे बढ़ता हूँ. Very nice. So it's a trick, a heavy trick which you guys can use. ठीक है? And one more trick I have given. If 3D8 is there and weak ligand is attached, 3D8, if weak ligand is attached in a coordination number, ये क्या हुआ? Coordination number 4, then it will always be sp3. And if 3D8 is there, if there is a strong ligand, then it will always be dsp2. ठीक है? Again, a simple trick which can help you find out the answers. ठीक है? Very nice. Moving on. Next question. I'm going here. Check this out. This question came in JEE Mains. Very interesting question, and it is actually a color wheel problem. Let us see how many of you will answer. Thank you, बच्चा. Avenger, come on. तुक्का नहीं मार, चलो तुक्का मारो, कैसा मर्जी मारो, कोई इशू नहीं, मैं समझाऊंगा. I'll give you the theory behind it. Very, very easy. Very, very easy. All right. The color of light absorbed by an aqueous solution of copper sulfate is. Absorbed पूछ रहा है. देखो बच्चों, the color you see around is always complementary to the light it has absorbed. You know, if you can see me right now, I'm absorbing some radiation in visible region. Some of them I'm giving it back. मैं वापस, it is coming to you. whatever the radiation that are coming back, you perceive them as color. ठीक है? So there's a very simple trick how to find out what color will be coming out. You guys already know that aqueous copper sulfate is blue in color, right? So some of you might have given answer B and got wrong. That is not the answer, because the color of the complex or color of anything you see is always complementary to the radiation it has absorbed. It will absorb some radiation, some of the radiation it will give back. Those radiations you see as color. This is a very, very important question. Answer will come from your favorite color wheel. Color wheel से आएगा violet, indigo, blue, green, yellow, orange, red. So check this out. The color absorbed is blue. What is opposite to, color which you see is blue. So what color of light has been absorbed? It must be orange. It must have been orange. So answer would become orange red. So there is a myth going on in the market that you need to mug up chemistry. They can ask you colors. Was there anything to mug up? I'm just, killing out all the myths. कुछ रटने का नहीं है. कुछ रटने का नहीं है. सबको समझ आया? सबको clear हुआ? What is the wheel? Color wheel. This is called as color wheel. So violet, indigo, blue, green, yellow, orange, red. The color of the complex is always complementary to the radiation it has absorbed. If it is absorbing some radiation in the visible region, some of it will give back. That radiation you see as color. Super trick. सबको मजा आया? सबको clear हुआ? सबको मजा आया? हाँ या ना? Yes or no? How easy this question is? Just let me know. Fill up the comment box as मजा आ रहा है. I'll move on to the next question. Right? सबको समझ आया? Orange, red? Such a nice class. So good. So good. So this is called as color wheel. ठीक है? Let's check out. JEE, again, I'm saying JEE has a habit of repeating the pattern. There is a repetitive pattern. Next question was again asked on color. This question came in 2012 mains. ठीक है? A very good question came again in 2014 based on color wheel itself. ये भी color wheel पे ही question है. बड़ा interesting question है. ठीक है? Check this out. Can you guys tell me what will be the answer? थोड़ा सोचना है because काफी अच्छा question था. थोड़ा you can take time and tell me the answer. What will be the correct answer? All right, let me do with you guys. The octahedral complex of a metal in which 4 monodentate ligands are there, L1, L2, L3, L4, absorb wavelength of light in red, green, yellow, blue respectively. The increasing, by the help of absorption of the light, they are asking ligand strength. How interesting question. This is a mind-blowing question. Let us go through it one by one. ठीक है? They have said octahedral. बच्चों, very simple thing. The color is actually because of, the colors are because of DD transition. If they have said octahedral, it means electron must be jumping from T2G to EG. What will happen? Electron would be there. It is absorbing some radiation. It is absorbing some radiation in visible region. Visible region means violet, indigo, blue, green, yellow, orange, red. It must have absorbed some color. As a result, it is going back up. The electron will jump. Okay? The electron will jump. And when it will come back, it will give out some radiations. Those radiation you can see as color. First point. ठीक है? सबको समझ आना चाहिए. This point is very important. All right. Now check this out. For different complex, splitting is different. And in my session, I have told splitting. If you check out my YouTube sessions, I'll help you out with the extra point. So this is delta naught is equal to HC by lambda. If your splitting is more, बच्चों, if your splitting is more, lambda would be less. ठीक है? Lambda would be less. If splitting is more, it means a very strong ligand is there. Its wavelength, it will absorb a very small wavelength. It will absorb a very small wavelength. If splitting is more, means ligand, which kind of ligand is there? A strong ligand is there. So it means the wavelength of radiation that it must have absorbed, the complex has absorbed, must be very less. You guys know violet, indigo, blue, green, yellow, orange, red. As we move from left to right, wavelength increases. So if a strong ligand is there, its wavelength should be, it must absorb light of very less wavelength. So guys, tell me the answer now. If a strong ligand is there, it must absorb wavelength of very strong, wavelength of very small wavelength it must absorb. To check this out, if I talk about L3 is absorbing blue. Where blue is coming here? It means L3 must be of, L4, I'm really sorry. L4 should be of highest strength, first point. Then violet, indigo, green. Green is absorbed by L2. Check this out. Where this option is? B option. L4, L2. Check this out. So the ligand which is absorbing blue light, it means its wavelength, its splitting should be very high, ligand should be very strong. Then next followed by green, followed by yellow, followed by red. So red, whichever ligand is absorbing red light, it means the splitting caused by it would be very less. It is a weak ligand. सबको समझ आ गया? सबको clear हुआ? क्या मजा आया? Easy question. How easy it is? Higher the splitting, it means ligand must have been very strong. For that, wavelength of radiation absorbed should be very, very less. You got that correct. मजा आ गया. बहुत interesting सवाल था. And again, can you guys see the pattern? Color पे भी सवाल आते हैं. A lot many questions come on color as well. Very interesting. Very nice. Moving on. Next question, बच्चा. Heavy question. Oh, love this question. Love this question. Love this question. You have to find GI. You call this GI. आपको GI बताना है. Geometrical isomerism. ठीक है? How many geometrical isomerism will be there in the case of a square planar complex? क्या आंसर है? Any answer? Any option? I'm getting mixed. I'm getting mixed answers. I don't know who's saying physics wala, no idea. For no reason. Very nice. So I'm getting a mixed answer. Answer still not coming right. I'll show you how. A lot many of you get confused by GI. Today you'll no longer be confused. I'll tell you a trick. Whenever such things will be there, what you will do, I'll assume you can see all the 4 ligands are different. So for my convenience, I'll assume A, B, C, D are the 4 ligands and M is the central metal atom. It will be very, very easy for us now. Okay? Now, A, B, C, D are the ligands, different ligands. I'm assuming them. Now you have to try hit and try. That's hit and try method is the only best method. Try to make up combinations. Take here. Hit permutation you have to use. Permutation combination. I'm fixing A. Now check this out. One combination with can be AB. Then it will become CD. One combination can be AC. Then it will become BD. Another combination that I can also get would be AD. And I'll get BC. Can you guys get any other combination out of these? Can you arrange the ligands in any different manner? क्या इसके अलावा कोई combination दिखता है? क्या इसके अलावा कोई combination दिखता है? Nope. So how many GI? How many GI? 3. खत्म कहानी. क्या मेरी बात सबको समझ आई? We have to just try hit and try method and make it easy for yourself by making A, B, C, D. Means these are the 4 different ligands. So there is only 3 GI. All these are going to show geometrical isomerism. Did we need to write any kind of structure for it? क्या हमें कोई structure बनाने की जरूरत पड़ी? क्या हमें कोई structure बनाने की जरूरत पड़ी? क्या हमें structure बनाने की जरूरत पड़ी? नहीं पड़ी. Without even drawing any structure, we got the answer. So this question is so easy and this came in 2015, JEE Mains 2015. Very nice. So answer is clear. Answer is B. आगे बढ़ता हूँ. Moving on. I'll get aside again. You guys will answer. Advanced problem, very easy problem. I want everyone to answer. जल्दी से बताइए. Vachal, you ask me later on, बच्चा. ठीक है? तो बच्चा बाद में पूछ सकता है. जल्दी बताओ. जल्दी बताओ. What is the answer? Very easy question. Find unpaired electrons. So I'll help you here. Fe. I'll just इसे साइड कर देता हूँ. So if I talk about Fe, FeF6 3 minus, है ना? So what will happen? X minus 6 minus 3. X will come as plus 3. So here Fe is what? 3d6 4s2. So Fe plus 3 will become बच्चों how much? 3d5. It means how many unpaired electron? 1 2 3 4 5. It has 5 unpaired electrons. So यहाँ लिख रहा हूँ it has 5 unpaired electrons. Check this out. This is P compound. This is P. Let's go for Q. Very easy. Q, vanadium is there. VH2O. अच्छा, H2O is a neutral ligand. H2O कैसा ligand है बच्चों? It is a neutral ligand. So X plus 0 is equal to plus 2. So X will come as plus 2. It means vanadium is 3d3, 4s2. So vanadium plus 2 will become 3d3. How many unpaired electrons? 3 unpaired electrons. सीधे ही बता दिया. Last one is what? FeH2O. 6 plus 2. I think you are getting it very clearly. This will become 3d5. Sorry, 3d6. 3d6 बन जाएगा. It means 1, 2, 3, 4, 5, 6. How many unpaired electrons? 4 unpaired electrons. Higher the number of unpaired electrons, higher will be the BM, higher will be the magnetic moment. So what will be the answer? What will be the answer? What will be the answer? So it should be P first. After that R. After that Q. So what is the correct option? Check this out. So P सबसे बड़ा होना चाहिए, फिर उसके बाद R. So answer would be B. I hope it is clear. सबको clear हो गया? Yes. How do I know? But at this point you have to learn that what is the electronic configuration. You have to learn this point. There is no other alternative. वो तो याद करना पड़ेगा configuration, ठीक है? All right. Moving on. Next question. Heavy session, and I'm loving the response. Check this out and answer me. What is the correct answer here now? Very nice, बच्चा लोग. Optical isomerism is also coming, don't worry. Thank you, bachcha. Thank you. Tell me now, what is the answer? You have to find oxidation number. Very easy. Let's go for this. First one. Chromium wala. X. Chromium. I'm going for chromium first of all here. So X. Water is a neutral ligand. I will say 0. If chlorine is outside, 3 Cl minus are there. So what will be the counter ion? Because the overall complex is neutral. So it should become plus 3. So here chromium is in plus 3 state. Okay. Chromium is in plus 3 state in your compound number 1. Let's go for compound number 2 or complex number 2 I should say. X, very nice. This is what? Benzene, phenyl group we will say benzene. ठीक है? It is a neutral ligand. कैसा ligand रहता है? It is a neutral ligand. ये याद रखना है. It can give all 6 electrons or it is actually a flexidentate ligand. It can change its way how it is attaching itself to the central metal atom. So it's a flexidentate ligand. 6 electrons भी दे सकता है. It can give 6 electrons as well. बहुत बढ़िया रहता है. But it's a neutral ligand. ये कैसा ligand है? Neutral ligand. So X plus 0. What is the overall charge? 0. So X will become 0. So in second compound, chromium oxidation number is what? Chromium oxidation number is 0. तो कहीं मिल रहा है देखो. C में भी आ रहा है, D में भी आ रहा है. Now we have a confusing point. Now we have a confusion. Check this out. Plus 6 or plus 4? Let's go for the last compound. बच्चों, very important. This oxygen is actually, this oxygen is actually coming as oxide. मतलब हमारा oxygen है, this is nothing but our oxygen. And oxidation number of oxygen is -2. But this is peroxide. This is peroxide. This point we have to know, otherwise this answer we cannot get. This is a peroxide. So check this out. X from chromium. Cyanide is, a negative ligand, -1 into 2. So -2. This plus -2 because oxygen is -2. Oxidation number is -2. How many times oxygen is there? 2 times. Plus peroxide is -2. And how many peroxides are there? 1. So -2. I'll write directly here -2. What is the overall charge? If you see the complex, if potassium is outside, 2 potassium is there, overall complex is neutral. It means the complex must have -2 charge on it. So from here, can you get? X will become plus 6. So answer is C option. How many of you got it right? How many of you got it right? सबको समझ आया? सबको क्लियर हुआ? D नहीं बच्चा, +6. +6, ठीक है? तो +6 आएगा. C would be the correct answer. Everyone is clear. C is the correct answer. It should pop up like this. I like the popping up of this screen right now. मुझे पढ़ने में ही नहीं आना चाहिए. Last वाले में क्या है देख ले. This O, this is nothing but oxygen. Oxygen oxidation number is -2. How many times it is repeated? 2 times. This O2 is superoxide. Sorry, I'm really sorry, peroxide. This you have to remember. And peroxide oxidation number is -2. O2 2 minus hota hai na? How many times peroxide is there? Only one time. So into 1. That's what I have done here. I hope it is clear. सबको समझ आ गया है? Very nice. मैं आगे बढ़ता हूं. मैं आगे और आगे बढ़ रहा हूं. ठीक है? Aha. A heavy question. A heavy question. Tell me the answer to it. जल्दी से मुझे आंसर बताओ. जल्दी से मुझे आंसर बताओ. What will be the answer for it? On treatment of 100 ml of 0.1 molar solution with COCl3 6H2O with excess of AgNO3, some precipitation is happening. These many ions are precipitated. The complexes. You guys know, if whatever outside is there, whatever outside of the square brackets, that can be ionized. ठीक है? If chlorine would be out there, it can react with AgNO3 and form AgCl, and it will precipitate. क्या मेरी बात सबको समझ आ रही है? Right? So for that very simple technique, very simple approach, what I will do here, check this out. I will take here, इधर लिख देता हूँ, यहाँ कर देता हूँ. So we have to find what is the complex. What should be the right complex? Some of you are giving the answer, and the answer is actually B. I'll go for the answer. Why answer is B? Check this out. Check this out. So I will find number of moles of AgNO3 that can be found. Let us find millimoles. वो आसान रहेगा. Millimoles निकालते हैं. Millimoles of AgNO3 will be equal to, लिख दीजिए, number of ions 1.2 into 10 power 22 divided by 6.022 into 10 power 23 into 1000, because I am finding millimoles. How much it will come? 20. Check this out. How many moles, how many millimoles of the complex are there? Millimoles of the complex, it will be molarity into volume in milliliter. So what will be the answer here? It will be 100 into 0.1. So it will become 10. Aha, it means out of, if I will pass AgNO3 to this particular complex, 2 Cl minus are going out. They are reacting with AgNO3. Means outside the square brackets, how many Cl's are there? 2 Cl's are there. ठीक है? So that's why, what will be the complex? देख सकते हो? यहाँ पे 10 आ रहा है, यहाँ 20 आ रहा है. Means on treatment of AgNO3 to this complex, AgNO3 is reacting twice with the chlorine. AgCl is formed twice. 2 moles बन रहे हैं, 2 millimoles उसके बन रहे हैं. 2 millimoles of AgCl has been formed. It means 2 Cl minus or 2 Cl minus are ionizable. That's what we are learning. Very nice. ठीक है? So यहाँ पर क्या आंसर आ गया? Answer would be B. सबको क्लियर हुआ? Let's move on to the next question. आगे बढ़ते हैं next question की तरफ. Moving on. Now एक काम करते हैं. We'll go for the optical isomerism. Many of you are asking for optical isomerism question which came in JEE Mains 2016. Try to answer this question. जल्दी से मुझे आंसर बताओ. I'll give you a trick. We'll end the session with this note. जल्दी से मुझे बताइए. What will be the answer? What will be the answer? Just let me know. जल्दी से बताओ. Very nice. Very nice. All right. I'm getting some answers. I'm getting some answer. बहुत सही. बहुत सही. A lot many of you are awesome. Some of you are just coming here to spam. I don't know why. कोई issue नहीं. Answer guys. I love the positivity. I focus on the positive part. I don't care about them. Very nice. Go ahead. बहुत सही. Aha! A lot many of you are giving right answer. I'm impressed. Answer is B. Very nice. देखो. Let me teach you a simple trick. Again, we'll go for GI, then we'll go for OI. This will be the very amazing trick you will learn today. Check this out. Here, if I will ask you for GI, for the A part, what you will do, metal is there, A3, B3. So what is the possible combination? M, A, so combination you make for GI. I'm asking GI right now. A, AB and BB. Apart from this, what you will get? A, AB, AB, AB. So how many GI if I would ask? You will say, sir, 2 geometrical isomerism. Can you get anything else out of this? कुछ और extra मिलेगा? Can you get anything extra out of this? नहीं. You will only get 2 GI. And if I will ask you, would it contain any optical isomer? I tell you a trick. Pay attention. Whenever you are making a pair and same ligand appears 2 times in it, or a same combination repeats itself you will say, sir, in that particular combination, no GI. So you will say here, no OI, optical isomerism will not take place. Very simple trick, need not to draw the structure also. If your pair having same kind of ligand, you will say, sir, GI to hai, but OI nahi hoga. There will be no OI. ठीक है? Here also you can see a pair, similar pair has been repeated. You will say here also, sir, no GI. So it is clear that this is not the answer. This is out of question. ठीक है? Coming to this one, एक बार D भी देख लेते हैं. Very simple. D is also very easy. D is very easy. Check this out. D is also very easy. What I will do again, I'll make the same combination. MA4 MA4B2 MA4B2. So what will be the combination? AA BB. One combination would be AB AA. Can we get anything else? OI is optical isomerism. The question is on optical isomerism. We call it as OI in short. Okay? Check this out. How many GIs, guys? How many GIs in this particular geometrical isomerism? How many geometrical isomerism? 2. Would there be any OI? Would there be any OI? क्या यहाँ पे कोई optical isomerism होगा? Would there be any OI? Would there be any OI? Yes or no? Yes or no? No. Pattern has been repeated. Pattern has been repeated. So I think I am giving you insight how to deal with optical isomerism with a proper trick. ठीक है? Very nice. This is also over. Now there is a bet in B and C. Let's check this out. देखो, EN is a bidentate ligand. Ethylene diamine tetra EN. So ethylene diamine is a bidentate ligand. It will form a bidentate linkage. ठीक है? It will form 2 bonds. ठीक है? Very important point. And it is a symmetrical ligand. Means both the donor atoms are same. In this case, nitrogen atom is the donor atom and it is same. So both the donor atoms are nitrogen. Check this out. How will I write this? So I am writing cis first. Cis. I am writing first trans. Now what you guys have to check? You have to check, is there any plane of symmetry? A plane of symmetry check karna. Can I cut this compound like this? A slice cut can happen. I'll show you like this. Imagine the ligands are like this. One ligand is here, one ligand is here, one ligand is here, one ligand is here. And one ligand is upwards, one ligand is downwards. Can I cut it slice? Can I cut a slice cut is there? Can I do it a slice cut? Yes or no? So it can be, a plane of symmetry. You will get similar ligands up and down. You will get similar ligands up and down. What you have to do? You have to do a slice cut. Whenever plane of symmetry is present, you will say optical isomerism will not exist. Optical isomerism will not exist. I repeat. What you go for here now, you will check, is there any plane of symmetry? You can cut the compound like, you have played Fruit Ninja? You have played Fruit Ninja? Yes or no? You have played Fruit Ninja? Just cut it from a slice cut, right? Slice cut marna. So what will happen? Above and below, you will get the same thing. You will say, sir, plane of symmetry is there. It means the compound cannot show optical isomerism. This is the simplest trick you can remember. Simplest trick you can remember. Okay? So automatically, what will be the answer? Answer would become B. We have less time. I would have gone on detail here as well, but detail abhi nahi ja sakta. So this is the way I have eliminated all the 3 options. I hope you are clear. Okay? Very nice. Moving on. So this is a crash course which is running on. If you guys want some help, we are here. आप लोग try कर सकते हैं. You can learn the entire chapter from us. We have a crash course which will help you for the JEE as well as it can also help you for the second attempt. आराम से आपको कर सकता है. First attempt के लिए तो बहुत crucial ही है. And it can also be used for the second attempt as well. This is a very good crash course we are running. ठीक है? One more thing I like to tell. I have done some heavy lectures, very good lectures on coordination compound, which are there on, if you want to learn specifically coordination chemistry, on our YouTube channel. You can check that out as well. वो भी है. I have explained in detail about optical isomerism, geometrical isomerism. You will get for free. वो भी free में मिल रहा है. This, if you want to learn way more, if you want to go much more in detail for the sessions, you can try the crash course where you can learn everything. ठीक है? बहुत सही. All right. So I hope I have brought some value and I have given you some good content and you liked something new, you learned something new in today's session. ठीक है? So I'll just take a, I'll take a goodbye note now. I hope you loved it. So if you liked it, subscribe it, share it, है ना, and spread the word. Make sure every one of your friends see the lecture and get some answers today. I hope it is a good lecture. Thank you so much. See you next time.